it's a cliche, right? But I actually asked, this is a name drop now, I asked Jeff Bezos that question once, and so there's a name drop. And he said, correctly, Earth. Right? Earth is the best planet. And that's true. So because of everything I've just said, right? I just said it's the only place where meaning exists potentially in a galaxy of 400 billion suns. So that would be your favourite planet as a result of that. But beyond that, it's in the solar system. So let's go to Elon Musk. Let's mention the other rocket engineer. So he wants to go to Mars. Might well get to Mars. That's the only other planet you could go to, actually, in our solar system, because Mercury is way too hot. Venus is horrendously hot, and 90 atmospheres pressure and sulfuric acid rain, it melts lead on the surface, right? So you're not going there. And the rest of them are made of gas, so you're not going there either. So Mars is the only place beyond Earth that we could feasibly ever go planet. We could imagine perhaps going to some of the moons of Jupiter and Saturn in the far future. That's much more difficult. I think we're at the frontier of a very exciting time in our history as a civilization, because we are now, I think, on the verge of becoming a spacefaring civilization in the truest sense of the word. Let's say multiplanetary civilization. So there's been a revolution in engineering in the last 10 years or so, the last decade, because now we have reusable rockets. So SpaceX, now Blue Origin, have reusable rockets, which means that access to Earth orbit is cheap, or at least cheaper than it's ever been before. So we are industrializing the space above our heads, just a few hundred miles above our heads, at an ever-increasing rate. Of course, it's been very important to us for many years, decades in fact. So satellite navigation, communications, weather forecasting, Earth observation, climate observation, and so on. The observation of Earth from Earth orbit has been part of our lives, whether we think about it or not, for quite some time. But now, because we have the technology to access it cheaply, I think we are seeing a revolution. And so it will not be long before there isn't just one crewed space station in orbit, which is the International Space Station. There will be multiple space stations in orbit. There will be scientific research at a much higher level in orbit, commercial scientific research. There'll of course be space tourism. There's an increasing demand on communications, for example. So the Starlink satellites, hundreds and hundreds of them up there. There'll be multiple competing constellations of satellites that allow us to make phone calls and access high-speed internet from any point on the Earth. And so that process is accelerating, and it is going to accelerate further. So what does that mean? So there's a tremendous opportunity. It's incredibly exciting. Before we start thinking, by the way, about going out to the asteroids and mining them and building cities on Mars and building cities on the moon and so on. But let's just talk about Earth orbit first. It's tremendously exciting, huge opportunity. But of course, when you start to move outwards to a new frontier, then the frontier can become crowded. You can have competition for the real estate. You need some way of managing conflicts between by which I mean physical conflicts between the satellites. What happens if someone's satellite comes close to another satellite? How do you manage that? Do you allocate particular orbits? Or do you say that we're going to have some framework like air traffic control, where you have an avoidance system that everybody agrees on, whereas if two things come close, they avoid each other? That framework is not yet there. I attended several meetings and conferences where there are, of course, many countries and international bodies that are trying to work on the management of space. I find that it's a challenge, because of course, it's always a challenge when different countries and different commercial interests and so on are trying to flesh out agreements about how you manage a frontier. But ultimately, I find it exciting, because what it means is we're now at the stage where, as the great Carl Sagan said, we're beginning to take our first steps out into the cosmic ocean. And I always remember, and he said, the water seems inviting. So it's a tremendous opportunity. But what kind of opportunities are going to open up? Well, we know, for example, so already from our experience on the International Space Station, that sort of development of new drugs, for example, or development of new ways of building semiconductors, for example, silicon wafers and so on. Lots of experiments have been done that suggest that there might be an advantage to on-orbit manufacturing. So it's in a microgravity environment of certain things, growing crystals and so on, which might be useful. And so as we begin to get more experience operating in microgravity, we begin to see that there are applications for particularly material science and biosciences. But beyond that, so when we start to move outwards beyond near-Earth orbit and build the infrastructure that we need close to the planet to begin to move further out into space, then opportunities begin to open up that I find tremendously exciting. So one very well-known example would be mining asteroids. So one could argue, there are people that argue, that one of the biggest problems we face and have faced historically on Earth is competition for resources. So not only just the pure competition, which leads to conflict and war if you think those resources are limited, which they are on Earth, but also just the stress, of course, that you put on the Earth itself, on the environment, as our civilization grows and requires access to more resources. It damages the planet, it creates conflicts and so on. But if you have the infrastructure to begin to move outwards, for example, to the near-Earth asteroids, then what you find is that resources are no longer limited in any reasonable sense. There are vast amounts of resources out there in space that we will have access to within the next decade or so, or certainly a few decades. So that begins to transform the way that we think about our civilization, the way that we think about expanding our civilization, increasing the capability of our civilization, and so on. I think there's a tremendous opportunity there to grow our civilization, crucially, without further damaging the planet that most of us will live on for the foreseeable future. And that's why, for me, I'm ultimately optimistic about those steps that we're making into space. I mean, I would not have imagined, I think if you went back 20 years, that we would have so many rockets flying and coming back to the Earth again, and then flying again. Perhaps within my lifetime, but certainly at this point in the 21st century.
But it's a great question. Yeah. So you could fly a rocket through the upper bits of its atmosphere, where it's not quite as dense. But if you go down towards the core of Jupiter, the pressure becomes so high and the temperatures become very high. We think there are all sorts of exotic materials. We don't really know what's at the centre of Jupiter. We have a spacecraft called Juno at the moment, which is orbiting around Jupiter to answer that very question, trying to work out what is actually in the middle. We think there are exotic things called metallic liquid hydrogen and all sorts of really strange materials. But if you tried to fly a rocket through the centre, it wouldn't get very far. It'd get squashed and crushed and melted. And then it may well hit something very solid indeed in the core. But these are great questions. That's such a good question that NASA built a spaceship to go and try and answer your question, which is there at the moment as we speak. So the answer is that no technological advances are required for us to go and colonise Mars, to visit Mars first and then colonise it. We have the technology now. Mars it's actually the only planet other than the Earth that we will ever colonise, I think it's fair to say. No, perhaps the moons around the other planets we could. So Mars is the only planet we'll colonise beyond Earth, but it's an easy planet to colonise. It's got water in abundance below the surface, we're sure, or frozen in the ice caps. It's got all the minerals that we need to build a civilization. We have the technology to go and extract the water and turn the water into oxygen and hydrogen for us to breathe and to make rocket fuel and electricity, all the things we need. There's lots of iron there, all the stuff you need to build a civilization. So we know how to do it. So it's just whether we want to or when we want to. We have the rockets that can take us there. And so anyone of your generation could walk on the surface of Mars. And I think you will if you want to, because we can do it. I think we will do it. And I think we'll do it I think we'll go there in the next 20 years. So when you're about the right age to be working on those missions, actually, I think we'll have permanent bases there. I don't know. Probably at that point, most of the plans I've seen to go to Mars involve setting up the base first with robots and then going to the base. So it's almost we build the base first and then we go and move in. And I think that's what we're going to do. Well, so terraforming is changing the atmosphere of the planet. And that's a longer term goal, but we can. We know that we could do it in principle. And ultimately, you'd want to grow plants on the surface when you made it hot enough. I should say that there's a place called Hellas Basin on Mars, which is a big, almost certainly an impact crater. Impact basin, actually. And it's so deep that if you stand on the edge of the rim of the Hellas Basin, it's 9 kilometers down to the floor. So that means that although it's so big you couldn't see it, if you put Everest in the middle, you could look down on the summit from the edge. You couldn't actually, because the summit would be over the horizon, because it's such a big thing, it's quite a big part of the planet. But it's so deep that the atmospheric pressure is so high at the floor of the crater that liquid water can occasionally exist at the floor. So already, although Mars's atmosphere is very thin, there are places that are so low in altitude that the pressure is high enough for liquid to exist momentarily there, even now. So you can see that the atmosphere of Mars doesn't need a lot. It needs things like a greenhouse effect, carbon dioxide and things thrown into the atmosphere. But then you can imagine growing plants, and the plants would produce oxygen, and the water's there for them to do that. And so you could imagine at some point in the future that we end up with an atmosphere on Mars again, because it did have one once. It's, as I said at the start, it's one of the questions I really want to know, and I think we might answer very soon. Obviously, if there isn't any, we'll never answer the question, because we can never say certain. I'll tell you why, actually. We've been measuring, so how many other planets are there, is the first question. Well, 20 years ago, just over 20 years ago, we didn't know of any outside the solar system. Now we know that virtually every star in the sky has a planetary system around it, at least one planet. We suspect from measurements from a telescope called the Kepler Space Telescope that there are maybe 20 billion Earth-like planets in the Milky Way galaxy. We've discovered close on, I think, confirmed planets, about 1,700 planets that we've actually confirmed exist. And so essentially everywhere we look, every star we look at appears to probably has a planetary system, so there are a lot of planets. So life on them, how could we detect that? Well, we're at the level now where with our telescopes we can look at the light. So you imagine a star and you imagine a planet passing across the surface of the star. Then the light, some of the light from the star passes through the atmosphere of the planet on its way to our telescopes, and that allows us to chemically analyse the planet's atmosphere. So we can look for signs of life in the atmosphere. An example on Earth would be oxygen. So the oxygen in Earth's atmosphere, virtually all of it, comes from photosynthesis. Without photosynthesis, we wouldn't have an oxygen atmosphere. So if you see a planet with an atmosphere filled with gaseous oxygen, then you might be pretty confident that there's photosynthesis on that planet. You might even, some of my astronomer friends speculate that what would happen if you found industrial pollutants in the atmosphere of a planet? You could do it. Things like CFCs, these things that we manufacture here that are not natural. You could find signs of non-natural elements, not only produced by plants, but produced by a civilization even. You could imagine that. So we have the chance, at least now, of analysing the atmospheres of these planets to look for life on them. As I mentioned earlier, the life on Mars, we're looking for that very seriously. Why? Because we think there's certainly a chance that it did exist at some point in the past, because we know water flowed over the surface of Mars. But we also strongly suspect that there's water below the surface of Mars now. And so any microbes that evolved perhaps many billions of years ago could have survived subsurface. So we may find life on Mars. So I think that's one of the potentially one of the great discoveries that, it's a guess again, it's not a particularly scientific thing to say. The reason we build big spacecraft to go and land on Mars is because we want to look. So we don't know. If we knew, we wouldn't go and build a spacecraft to go and have a look.
Yeah.
So, but yeah, I think it's very exciting actually at the moment now. You're right. If you ask the question about life, the answer is we don't know. We've found nothing alive beyond the Earth, but admittedly we haven't been very far or looked tremendously hard. Although we are looking hard now on Mars because we suspect there might have been microbes on Mars because there was once water on Mars and it was geologically active, and all the things that we think led to the origin of life on Earth were present on Mars around the same time, about 3.5 to 4 billion years ago. So we wouldn't be surprised if we find that microbes existed, probably subsurface on Mars, or maybe on some of the moons of Jupiter or Saturn where there's water today. However, nobody expects anything more complicated than a microbe. And it's interesting, if you look at the history of life on Earth, you have microbes around 3.8 billion years ago, pretty much, not long after the Earth formed in geological time. But if you look for evidence of complex life on Earth, then really there isn't any in the fossil record until about 600 million years ago or so. So on this planet, for most of the history of the planet, there was slime, basically, single-celled things, doing interesting stuff, photosynthesis and things, but nothing more complicated than a single cell. And it's only in the last 500 million years or so that you get this explosion of life on Earth. And only, as I said, it's only in the last less than 1 million years that we've had Homo sapiens on Earth. And in the last few tens of thousands of years, we've had a civilization. So here, it took pretty much 4 billion years to go from cell to civilization. And that's a third of the age of the universe. And so that leads many biologists that I speak to suggest that whilst microbes might be common, civilizations might be rare. Actually, I asked a friend of mine, a great physicist, Sean Carroll, how many civilizations do you think there would be in the Milky Way galaxy, a typical galaxy? How many in a typical galaxy? And he said, none. Again, superb question. There are two answers to this. There's a simple answer. And the simple answer is to think about a planet like Mars. So Mars is a small planet compared to the Earth. And so what does that mean? Well, it means that its surface area is larger in relation to its volume. So the fundamental law of things, that as you increase the size of something, then its surface area to volume ratio decreases. Right? So something small has a big surface area and little volume, something big has a small surface area and a big volume. You see this in the natural world actually, in animals. So things like little mice and little bats and things have to work a lot harder to keep their body temperature than things like elephants for the same reason. So you apply that to a planet. So all planets, when they form, you've got loads of rocks coalescing together. They come together, you get heat in the centre. That's added to by radioactive decay in the centre of the planets. So you've got a certain amount of heat in the core, and it's been radiated off into space. And the smaller the planet, the faster it radiates the heat through its surface, because its surface is bigger in relation to its volume, which is kind of proportional to the heat. So you would expect a planet like Mars for its core to solidify. It loses its heat, the core solidifies. You've not got this nice iron core that can spin around anymore, the liquid iron core, molten iron core. And so you lose the magnetic field. Fine. So that's roughly speaking what happens. Jupiter is a bit more complicated because it generates its own heat. And that's mainly to do with its collapsing in and the high pressure and the condensation of liquid, all sorts of things. It's kind of cool. You should look it up on the web actually. It's got loads of interesting properties. It's not like a star. It's not big enough and massive enough to do nuclear fusion, but it has, because of its immense mass, there's a way of it generating its own heat in the core. But then, so we say all those things, so it's good. The Jupiter's very big, the Earth is big, Mars is small, Mars cools, field goes away. Then, though, last year we go and fly past Pluto, which is tiny and on the edge of the solar system, And we find that it's a geologically active world, or has been in the very recent past, which means there's a heat source in the middle. So you say, why? How is there a heat source in the middle of this tiny thing? It should have lost all its heat. And we don't really know. I think one of the speculations is that it's radioactivity again, and that for some reason there's more radioactive elements in the core of this thing on the edge of the solar system. We're going to another one now, another minor planet. Actually, the New Horizons probe is going to have a look. So is that the same? Does it show signs of geological activity or not? We don't know. So it's a great lesson actually in science, that when you think you have a really general law in planetary science in particular, and then you go to another planet or a moon or a minor planet and it just doesn't fit. They never fit.
In science, at the moment, space science, we have this debate a lot actually, because of course space probes like Curiosity that's on Mars at the moment, that's really cheap compared to sending people to Mars. And so quite often the scientists who want to find out about the world will say, well, we should spend it on robots, we shouldn't spend it on people. I think crewed space exploration is in some ways, I mean, it's clearly true at the moment that humans can do more than robots, so we can explore the place better.
For now.
Yeah, but I think it has to be, it's about something else. I mean, it's about, and it's not only, it's about living and working off the planet, which I think is quite a persuasive argument actually. We've already industrialised near-Earth orbit, so it's already a multi-billion-dollar industry, communication satellites and weather satellites, GPS, whatever. We're already up there. And so learning to live and work in space is, I think, a natural extension of our civilization. The amount of resources available just slightly above our heads is vast. And so I remember I talked to Jeff Bezos actually once, and he thinks really simply, and he said, for example, in the asteroid belt, there's enough metal, I think, to build a skyscraper. What is it? It's something like 800 stories tall and cover the Earth in it, right? If you want. Now, we don't want to do that. But his point was that the energy from the sun is all up there, the resources are up there. So you could almost imagine trying to zone the Earth residential at some point in the future to protect the planet and do your heavy industry off the planet, for example. And it sounds like science fiction, except that now SpaceX and Blue Origin, those people have got reusable rockets. So suddenly the economics become sensible. So I think expansion is good. And I think we will expand, and I think we will expand outwards, because there's not much room left on this planet to expand. So I think we'll do. So, but that's a whole different idea. It's not about gathering scientific information. It's about a frontier and all the benefits that come from operating as a civilization on a frontier, which we've sort of lost on the Earth because there is no frontier left. And so I like that idea that Mars. And when you talk about Mars, especially with Elon, he's right that that's the only place you can go. So there is no other planet we can go to other than Mars. You can't go to Jupiter or Saturn. You can't go to Mercury or Venus. So if we want to go somewhere and expand our civilization, it has to be Mars, and everything's there that you need. So, but that's a different thing to saying you want to find out stuff. You're right. If we just want to find out stuff, then you send robots. I'm not going to go there till there are vineyards and hotels and things. But however, it is true that there are people who like the challenge. And what is true about Mars, it's interesting actually, because we know something about the history of Mars now, quite a lot about the history of Mars. And it's certainly clear that there was water, almost certainly oceans, rivers. So, and that water is almost certainly still there. So, yeah, so there's certainly ice. There may even be pockets of liquid water below the surface somewhere. So couple that with all the minerals and the resources that we know are there, and you have everything you need. So that's the thing about Mars. It's quite nice relative to everywhere else other than the Earth. You can't go to Venus, right? You just melt. It's, 400 and something degrees and 90 atmospheric pressure.
Yeah.
So Mars is quite nice. But I wouldn't go there. I agree with you. There is still gravity. It's a bit more than a third. I can't quite remember, but it's something like that. But yeah, so there's still gravity. Right. So there's gravity. There's some protection from you'd probably want to live in the caves actually, or something like that, because there's no magnetic field there, so it's quite a high radiation environment, but not too bad. It's further from the sun than we are. It's not too. There are places on Mars. There's a very deep crater called Hellas, which is a big impact basin, and at the bottom, it's so deep you could fit Everest in it. So if you put Mount Everest in there, the summit of Everest wouldn't reach the rim of the crater. So it's something like, I don't know what it is, 7 miles deep or something, 6 miles deep. So you could go there, and at the bottom, the atmospheric pressure is so high that you could just about have liquid water occasionally on the floor of that crater.